Hello students, welcome to today's lesson. We are looking at a subtopic known as molar solutions. In our previous lesson, we looked at the molecular formula. So that was part 4. Today we look at part 5, which we are calling the molar solutions. So we start by defining what a molar solution. What is a molar solution? And a molar solution is a solution that contains 1 mole of a solute per liter of solution. So we know what is a solute. So a molar solution is a solution that contains 1 mole of a solute per liter of solution. Then we are going to define two terms that we are going to look at under molar solutions. So the first term we are going to look at is what we call molarity. And molarity is usually abbreviated as capital M. So molarity, we say it is a measure of concentration of a solute in a solution, the measure of concentration of a solute in a solution. It can also be defined as moles of a solute per liter of a solution. So this definition is very important. Molarity is the moles of a solute per liter of solution, because we are going to use it as we start the calculations based on molarity. So molarity represented mathematically can be written as M is equals to N over V. N is the number of moles. That is what we are saying, it is moles of a solute. So the number of moles over or divided by the volume of the solution in liters. So in liters is very key. Never forget to indicate that the volume must be changed into liters. So molarity is equals to number of moles over the volume in liters. That is why we are saying in its definition, it is the moles of a solute per liter of solution. Then the second term we look at is concentration. And what is concentration? Concentration is defined as the amount of solute contained in a given volume of solution. So this is the amount of solute in a solution. Then concentration is expressed in two ways. One, in grams per liter, which is being represented as G over L. So that is grams per liter. So if you are calculating concentration, your answer can be given in grams per liter or in grams per decimeter cubed. That is the same thing. Then the other way we can express concentration is in moles per liter. So that is mole per liter or moles per decimeter cubed. So that is the same. So that is two ways we give concentration, grams per liter and moles per liter. So now we are going to look at examples concerning or based on molarity and concentration. So we are going to start with concentration, and we have our first example here. We are asked to calculate the concentration of 10.69 grams of sodium carbonate in 250 centimeters cubed of solution. First, we calculated in grams per liter. So we are finding concentration. We said we can express concentration in two ways. One, in grams per liter and in moles per liter. So we start by giving the concentration in grams per liter. So we said we have been given the mass. So the mass is 10.69 grams. So this 10.69 grams of sodium carbonate is being dissolved in 250 centimeters cubed of that solution. So we have 10.69, we are equating it to a volume of 250 centimeters cubed. Then we asked ourselves, what about 1 liter, which is the same as 1000 centimeters cubed. So that's why we are having 10.69 is equals to 250. What about 1000? Then we cross multiply here. So we are going to get 10.69 times 1000 centimeters cubed divided by 250, which is giving us 42.76, and that is in grams per liter. So that's simple. We just equate the mass of the solute we are given, that is sodium carbonate, to the volume that is being dissolved in. Then we ask ourselves, what about in 1 liter, which is the same as 1000 centimeters cubed. Okay, so now that is the first way we are going to express the concentration, that is in grams per liter. The second way we are going to express this concentration is in moles per liter. So what we need to get first is the number of moles. And how do we calculate moles? Moles, we have been calculating moles using the formula mass over the molar mass. In this case, it is the RFM, the sodium carbonate. So the molar mass is the relative formula mass. So the mass is 10.69 grams, and the molar mass of the RFM of sodium carbonate is 106. So that is sodium plus sodium, that is 23 times 2, that is 46, plus carbon, that is 12, plus 3 oxygen, that is 48. That is what is giving us 106. So the number of moles of sodium carbonate in a mass of 10.69 grams is 0.1008 moles. Now we can say 0.1008 moles is equivalent to 250 centimeters cubed of the solution. What about 1 liter, which is 1000 centimeters cubed? So what we need to do here is just cross multiply 0.1008 times 1000, then divide by 250. So this is what is giving us 0.4 moles per liter. So that is how we express concentration in moles per liter. Another alternative that we can calculate concentration in moles per liter is where we take the concentration in grams per liter, then we divide by the RFM. So for this case, we can say concentration in moles per liter is equals to concentration in grams per liter, which we got as 42.76, then divide by the RFM of sodium carbonate, which is 106. So this will also give us 0.4 moles per liter. So this is another method or another alternative to calculate concentration in moles per liter. We look at another example. So here we are given 3.0 grams of magnesium sulfate in 1000 centimeters cubed solution. So we are finding concentration in grams per liter and also in moles per liter. So we start in grams per liter. We repeat the same procedure. We say the mass is 3.0 grams. It is equivalent, or it is dissolved in 1000 centimeters cubed, right? So what about 1000 centimeters cubed? So 3.0 grams is dissolved in 100 centimeters cubed. What about in 1 liter? So what about in 1000 centimeters cubed? So this is where we are going to cross multiply. So we have 3 multiplied by 1000 divided by 100. So this is where we are getting 30 grams per liter. So that is concentration in grams per liter. Then B, we calculate the concentration in moles per liter. Again, moles or the number of moles is given by the mass over the relative formula mass. The relative formula mass is given from the formula of magnesium sulfate. We have magnesium is 24, sulfur is 32, and for oxygen we have, that is 16 times 4 to give us 68. So the RFM is 104. So the number of moles we are going to have mass, which is 3.0 grams, divided by 104, which is the RFM, to give us 0.02885 moles. So now we have the number of moles. We can get concentration by saying 0.029 moles is dissolved in 100 centimeters cubed of the solution. What about in 1000 centimeter cubed, which is the 1 liter? So this is given by, so to get the concentration, we multiply 0.029 moles times 1000 centimeters cubed, then divide by 100 centimeters cubed. The centimeter cubed and the centimeter cube will disappear. So this will be 0.29 moles per liter. Yes, or alternatively, we can use the other formula where we are saying concentration in moles per liter is equals to concentration in grams per liter divided by the RFM. So concentration in grams per liter was 30, the RFM is 104. So divide 30 divided by 104 will give us also approximately 0.29 moles per liter. So that is how we calculate concentration. First get the moles, get the number of moles, then equate it to 1000 centimeters cubed of the solution, or get the concentration in grams per liter, then divide by the relative formula mass. So that is how we calculate concentration. We have example 3 here, where we are given 4.0 grams of sodium hydroxide being dissolved in 200 centimeters cubed, then made to 250 centimeters cubed of the solution. We are asked to calculate the concentration in grams per liter and in moles per liter. So our solute here, sodium hydroxide, was first dissolved in 200 centimeters cubed. Then the solution was topped, or it was made up to 250 centimeters cubed. So it was, now the sodium hydroxide is being topped, or it is being dissolved in 250 centimeters cubed. So this is the volume we are going to use. So note that we are not going to use the 200 because it has been added 50 centimeters cubed more. So 40.0 grams is being dissolved in 250 centimeters cubed of the solution. What about 1000? Then cross multiply to get 16 grams per liter. So that is how we calculate the concentration in grams per liter. Again, in moles per liter, we say moles. We first calculate the moles, and moles is given by mass over the relative formula mass. The mass is 4.0 and the relative formula mass is 40. So the number of moles is 0.1 moles. The RFM of sodium hydroxide is 40. So after getting the number of moles, we equate to the volume that the solute is being dissolved in. So we have 0.1 moles is being dissolved in 250 centimeters cubed. What about 1 liter? What about 1000 centimeters cubed? So here, after we cross multiply, is where we are getting 0.4 moles per liter. Or else you can just take 16 grams per liter, that is concentration in grams per liter, divided by the RFM, which is 40. So 16 divided by 40 will also give us 0.4 moles per liter. Okay, now we go ahead and look at molarity. So we said molarity can only be expressed in moles per liter. So we don't get the molarity in grams per liter as to what we have done previously in concentration. So molarity we only calculated in moles per liter or moles per decimeter cubed. So for example, in our example 1 here, we are being asked to calculate the molarity of the solution formed when 34.8 grams of potassium sulfate was dissolved in 500 centimeters cubed distilled water. Now, this is just concentration, the way we have been calculating concentration, but now we give it in moles per liter, or we express it in moles per liter. So the steps are the same. We get the moles, number of moles, where we have mass over RFM. The mass is 34.8 divided by the RFM, which is 174, to give us 0.2 moles. Then 0.2 moles is being dissolved in 500 centimeters cubed of distilled water. What about 1000 centimeters cubed? So this one is where we come and cross multiply 0.2 times 1000 divided by 500, which is giving us 0.4 molar. So we use the capital M for molarity. Also, we can use the formula where we say molarity is equals to number of moles divided by volume in liters. So we have calculated the number of moles to be 0.2, then divide by volume in liters. Volume is 500. So to convert 500 centimeters cubed to liters, we divide by 1000. So this will be 0.2 divided by 500 over 1000, which will also give us 0.4 molar. So that is the second method we can use to calculate molarity. We look at example 2 here. We are told to calculate the molarity of 5.3 grams anhydrous sodium carbonate dissolved in 50 centimeters cubed of the solution. So the molarity, we said it is given in number of moles divided by volume in liters. So we first calculate the number of moles. That is always the first step. The number of moles is given by mass over molar mass. So that is 5.3 grams divided by the RFM of sodium carbonate, which is given by sodium is 23 multiplied by 2 to get 46, plus 12 for carbon, and plus 16 times 3 for oxygen, which is 48. So the number of moles are 0.05 moles. Then to get molarity, we said number of moles, which is 0.05 moles, divided by the volume in liters. So volume is 50 centimeters cubed. Change it to liters, divide by 1000. So the molarity is given by that, which is 0.4 molar. Okay, so there's a takeaway question there. We can find the molarity when 5.3 grams hydrated sodium carbonate decahydrate is dissolved in 50 centimeters cubed solution. So it is the same question, but then this one is decahydrate. So it contains 10 molecules of water. So you can follow the same procedure and find the molarity of that solution. Example 3, we are asked to calculate the mass of 20 centimeters cubed of 0.2 molar sodium hydroxide. So here we are given the volume and the molarity. So we are asked to find the mass. So to get the mass, we must have the number of moles. So the first thing is to get the number of moles, and we are going to calculate the number of moles from the formula of calculating molarity is number of moles times the divide by the volume in liters. So to get the number of moles, we multiply molarity times volume in liters. So this is where we multiplied 0.2 molar multiplied by 25 over 1000 liters. So the number of moles is 0.05 moles. So the number of moles will assist us in getting the mass, because we know mass is equals to number of moles times the relative formula mass. So to get the mass here, we are going to use the 0.005 moles of sodium hydroxide, then times the RFM, which is 40, to give us 0.2 grams. So the mass of the mass used to make the 0.2 molar sodium hydroxide solution was 0.2 grams. Again, there's also a takeaway question here where we have calculate the mass of 20 centimeters cubed of 0.625 molar sulfuric acid. So you just need to know the RFM of sulfuric acid, calculate the molarity, the number of moles, then the number of moles will give you the mass. The example number 4, we are calculating the number of moles now of sodium carbonate present in 100 centimeters cubed of 2 molar sodium carbonate solution. So this is very simple. We are given the volume and we are given the molarity. So we are to calculate the number of moles. We use the formula molarity is equals to number of moles of volume in liters. So now to get the number of moles, we just multiply molarity times volume in liters. So number of moles will be given by 2 molar multiplied by the volume, that is 100 centimeters cubed, convert it to liters, so divide by 1000. So the number of moles will be 0.2 moles. And that will be the last example and also the end of part 5. So let's meet again when in the next lesson as we look at how to prepare molar solutions.